think about this for a second. What actually happens when your application takes just 2 seconds too long to load? Now, out here in the physical world, 2 seconds is a blink. It's nothing. But in a digital ecosystem, oh, it is an absolute eternity. That tiny little delay triggers a massive cascade of negative impacts. User friction immediately spikes. Transactions get abandoned right in the middle. Your customers? They pivot instantly to your competitors. And your brand equity takes a very real, measurable hit. A 2-second latency spike isn't just some quirky technical anomaly. It is a direct hemorrhage of your revenue.
All right, let's look at section 1, the cost of slow apps. Because let's face it, performance is no longer optional. We're operating in a reality that basically has a zero-tolerance policy for latency or downtime. Users today just expect instantaneous, frictionless interactions everywhere. It doesn't matter if they're executing high-frequency trades on a financial platform or if your team is managing a global supply chain through an internal portal. Any degradation in performance is no longer just a temporary annoyance. To the modern consumer, a slow system is virtually indistinguishable from a complete outage.
Which brings us to section 2, the modern complexity trap.
So why is keeping things fast so incredibly difficult? Well, delivering that flawless performance is getting tougher because modern architectures are just so highly fragmented. Think about it. A single user transaction today triggers asynchronous calls across dozens of ephemeral containers, serverless functions, microservices, and third-party APIs. Because it's so incredibly distributed, a cascading performance issue can strike anywhere at any time. When data is hopping across all these dynamic environments, manually tracking a point of failure is nearly impossible. Relying on traditional monitoring here, it's literally like trying to map an evolving galaxy with a magnifying glass.
Okay, let's dive into this and look at the solution. Section 3, why you need APM. Application performance monitoring is your essential bridge to achieving true end-to-end observability in all that chaos we just talked about. It's engineered to ingest, contextualize, and analyze absolutely massive streams of telemetry data. We're talking metrics, logs, traces, giving you complete visibility into how your apps behave in actual real-world conditions. APM empowers your engineering and ops teams to continuously monitor system health. It automatically maps out dependencies and proactively identifies those sneaky bottlenecks long before they ever turn into a massive headache for your users. And let's connect this back to the business, because technical latency maps directly to your bottom line. An unoptimized query during an e-commerce checkout, that immediately results in an abandoned cart and lost cash. A persistent lag in an enterprise SaaS dashboard, that translates to stalled workflows and severe lost productivity across a whole organization. Or what about video streaming? Constant buffering doesn't just annoy viewers, it actively drives them to cancel their subscriptions and jump ship to a competitor. Robust observability steps in and intercepts these failing user journeys, essentially turning potential churn into preserved retention. And this all ties back to a foundational operational metric you're probably very familiar with, MTTR, or mean time to resolution. In these highly distributed systems, just finding the exact origin of the latency is usually the hardest part of the battle. Is it a slow SQL query? Is it an exhausted connection pool? Maybe a failing external API? Well, APM comprehensively traces requests across your entire application stack, giving context to that telemetry to pinpoint the exact root cause. This precision dramatically reduces your MTTR, transforming what used to be a chaotic incident response into targeted, highly efficient remediation. Let's move on and see how this builds in Section 4, APM implementation and impact. When you implement APM, you establish a continuous feedback loop of critical performance data. We're talking response times, throughput, error rates, CPU and memory usage, database performance, request traces, and overall system availability. But don't make the mistake of thinking these are just isolated engineering metrics. These technical insights translate directly into key performance indicators for the actual business. They dictate your transaction success rates, they determine your SLA compliance, and they give executive leadership a crystal clear view of how infrastructure health is either protecting or threatening the bottom line. Imagine this scenario. You have a critical mobile application that suddenly starts degrading. You've got a standard API response time that's been humming along beautifully at 200 milliseconds, and then bam, it spikes to a full 2 seconds. Now, without observability, this triggers immediate panic. Engineers are spending hours sifting blindly through logs across disparate systems, all while the customer support channels are absolutely flooding with complaints. But if you have a properly configured APM agent, it detects that massive deviation from the baseline the very millisecond it occurs. So instead of throwing together a chaotic war room, your response follows a precise, automated path. First, the 2-second delay is flagged instantly. Next, through distributed tracing, it identifies the specific bottleneck. Let's say it's an unindexed database query. And because APM integrates seamlessly with your deployment pipeline, it correlates that faulty query directly to a microservice deployment that went out just an hour ago. It can even isolate the impact to users in a specific availability zone. So a process that honestly would have taken days of manual correlation without APM is now resolved in minutes. The operational contrast here is just staggering. Operating without APM forces you into a purely reactive posture. You're dealing with high MTTR and the completely unacceptable reality of finding out about system failures because angry customers are complaining publicly. By then, the reputational damage is already locked in. But with APM, you're proactive. Your DevOps and SRE teams are executing confident, rapid deployments because they can immediately measure the performance impact of every single new release. It shifts your entire engineering culture from constantly fighting fires to strategically optimizing your code in real time. So I want to leave you with this final, critical thought. Are you truly protecting your customer trust and your long-term success in a cloud-native world? Because in today's interconnected, incredibly dynamic architectures, blind spots are systemic vulnerabilities. Investing deeply in application performance monitoring is no longer a luxury. It is an absolute strategic necessity to ensure your digital experiences remain fast, resilient, and continuously optimized.